Yeah, you're not sure that. Yeah, I'm curious, Jeff. See if you can hack it, dude. If you're bored, Jeff. If you're bored of us doing physics questions and stuff, feel free to go at it. Okay, cool. This is this is Anthony's question. Jeff hacking into the mainframe.
Oh
no. Okay, here we go. Anthony says, okay, here's a chain rule. Cool. Chain rule's dope. I think the way they explain it with this is sometimes like really confusing.
No.
So, you let me know if you understand the chain rule. Totally cool. If you don't understand the chain rule, I can kind of like show like why it works and stuff. 1 second. Look at my chats going. There, all the chats are up. Okay. So, yeah, they call this like Leibniz notation. There's actually a funny story about this. Leibniz and Newton both discovered calculus at the same time, but they were at different ends of Europe. And it's kind of one of these weird things where you're like, wait a minute, how did two people, you know, because they didn't have the internet, they weren't like DMing each other.
No.
How did two people on like opposite ends of a continent come up with the same like derivations for things at the same time? It's pretty cool. So Leibniz showing up in calculus is kind of like, you know, it's a little. Newton ended up getting all the credit, but like Leibniz like shows up a lot because he's, you know, he got like the consolation prize. Okay. So yeah, they say this. They say that dy dx is equal to, and let's use some colors here. Here, let's do this. Let's say dy. I'm going to use green for dx. Dx. And then they're going to say this is equal to like dy du, and then du times du dx. Now, just from like a, just in terms of just looking at the fractions and stuff, do you see how like du cancels with du?
That's dope.
And so you would literally just get dy over dx. So you can kind of see just from simple algebra that works, but let's think about like why this is, okay? So it says here, determine the equation of the tangent line on this, right? So determining the equation of a tangent line means I need the derivative of h of x, because the derivative will get me the slope of the tangent line. So I want h prime of x, and that's where you need the chain rule. Oh no, the math nerds are going to get really mad if they see you say cancel. Yeah. Yeah, they absolutely hate that. They get really mad if I do this. Yeah, they're not big fans of that. Okay, so let's figure out h prime of x. So I know that h of x, let's call that like y, right? Let's say that y is equal to the square root of x squared plus 2x minus 1. Yes, Bailey, if you want to submit your question to our website, it'll get added to the queue and it might get picked as the next question. My defense is working great. I'm pretty sure I had it banned at the, yeah. And do you see how there's a hash? That's your IP address. Got you, Jeff. Okay. Let's say this is the function, and we're trying to find y prime. All right, so y prime, which is equal to, that's just a fancy way of writing dy dx. That's what we're trying to figure out. It's your IP address, like, in some weird code that isn't, I don't think it's reversible. Square it? No, we don't want to do that.
No.
Watch. Okay. So, here's my question. How do I take the derivative of the square root of all this garbage? Right? I don't really know how to take the derivative of the square root of a bunch of shit. And in fact, instead of calling it a square root, let's put an exponent on it. Let's just do it this way, right? So what I say is, I don't know how to take the derivative of all this stuff to the 1/2, but I do know how to take the derivative of just something to the 1/2, right? And so I like to use like a little box. So let's say, okay, well, let's pretend that I need to take the derivative of the box, right? Well, the derivative of this, which is the same thing. Here, let me like move this over. Let's say like dy du. That would be the same as just doing 1/2 times this to the negative 1/2. Yeah, chain rule. Yeah, common chain rule. It's calculus Chad Light chain rule. We're doing derivatives. So this is 1/2, right? And then it would be box thing. And then this would all be to the minus 1/2, right? And then here's kind of like the price. Whenever you put like a box over something and saying like, oh, I'm gonna make it simple and take that derivative, I then need to technically also multiply it by the derivative of what my substitution was. And in that case, that's multiplying by the derivative of the blue thing with respect to x, which is the same thing as du dx. So that's ddx of whatever the box is. Okay. So, this first thing, right? That got me 1/2. It is kind of like u substitution. What's up, Amir? So that's 1/2 times whatever we pretended our blue box was. There you go. You got a big sports today. Whatever that is, to the 1/2 times the derivative of what the blue box was. And I know the blue box was x squared plus 2x minus 1. So then ddx of this thing. Yeah, sorry, negative 1/2. Yep. My bad. Yep, I forgot the minus. So then the derivative of the blue box with respect to x, right? Well, this is now 2x plus 2. Okay? Do I know the Diddy method? What? What's the Diddy method? No. Anyways, okay. So your final answer becomes 1/2 x squared plus 2x minus 1 to the negative 1/2 times 2x plus 2. And the reason why I wanted to like show all that, right? So this and this was here. This was ddx of x squared. Is Diddy here? I heard Diddy. Where is he? Probably at Costco getting baby oil, dude. So, Anthony, let's just go over it again. So, if I want to take the derivative of this, I pretend this is just something imaginary. I do that derivative, and so that's 1/2 times this now to the minus 1/2. But then I need to multiply by the derivative of what was inside, which is 2x plus 2. And what's kind of the cool thing here is this right here was dy du, and this part right here was du dx. Or, yeah, like this. And that's why dy dx, right, if this whole thing here is y, is equal to dy du times du dx. What's up, 1K? Good to see you.
Yeah.
Wow, look, there are all the questions. Yeah, nice. Okay. Cool. All right. Pretty bad way of explaining it, to be honest. This is that because it is. Well, I mean, yes, I could get down to the nitty gritty of why the chain rule works, but I think that would just scare most kids.
Oh shit.
And I think it's cool to eventually get there, but when a student says, I don't fucking understand the chain rule, I think the best thing to do is to show them procedurally, like, how to do it, so that they get confidence in that they can do it. No one wants to learn about, like, why something is if they have no fucking clue how to even use it. You know? If you didn't know how to drive, would you really care how a car works? You know? Yeah. You got it. Okay, cool, Anthony. Thank you. It's all good. No, and I appreciate the... Oh, the way it's taught in general. Yeah, thank you, Archibald. Yeah. Again, no offense taken. Yeah, you're fine, dude. I'm just saying, yeah. Yes, you could do that. You could do f of x and g of x. That's another way to do it. Math is application, not for exploration.
You're not that bad, trust me. You're
Don't
not
tell
that
the
guy.
math people that, dude. They get super upset. Yeah. Anyways, so yeah, if you want to see like why this works later, there are like a lot, you know, Archibald is correct. There are a lot of really cool applications for the chain rule. And yes, there's things like Lagrange notation, and you can get into all these other cool little rabbit holes. And I implore you to check those out, maybe when you get older, because this is probably your first calculus class. Solids of Revolution. Yeah, I literally just did a bunch of TikTok videos on those. What's up, Anthony? The only thing is, okay, you tell me, Anthony, what's confusing though? Because this can also become like a triple rule and like a quadruple chain rule and stuff. He won't put negative exponents. That's okay. So if you want to see what this would be like without the negative exponents, that's totally cool. So negative exponents just means you flip it and make it a positive exponent. So in this case, this would be 1/2. This is going to be flipped. So this is going to be 1 over sorry, all of this to the 1/2. Can you do Harvey next? You can vote for Harvey. Do you see on the website? So this, we changed some cool shit. So if you go to the live queue here, by the way, you can go to Harvey and you can go upvote his thing. And if you upvote him, he has a better chance of getting the next question. This is the percent chance right now. It's kind of like a lottery. Okay. So that's what this would be. My fellow brothers in math, please vote for me. And then this is 2x plus 2. So the absolute, and then there's another cool thing here, Anthony, by the way, is that the 2 here could cancel out the 2 in each one of these, because this is the same thing as 2 times x plus 1. And so this would cancel with this. So then you'd get x plus 1 over, and then anything to the 1/2 is the same thing as the square root. So you could say square root of x squared plus 2x minus 1. I think this is the safest way that your teacher wants it. Yeah. Does that make sense there? How that works? That's beautiful. Okay, awesome. Great. Yeah, I love it. Good job. Now I see why derivative U substitution works for antiderivatives. Yeah, it is cool. Very, very cool, Rook. It's cool how it works like that as well. Okay, awesome. So here's the cool thing here for everyone who's watching, just to like see how this works. Because again, some of you guys are new. You just found us. Anytime we do a question, such as yours, Anthony, it gets added to our Discord. So if you go join our Discord, which is the same website you use to submit your question, you'll see that your question will pop up here in like the forum. And there it is. See, there's yours. And then what we do is we'll drag the screenshot of the solution. It's right there, so you can go look at it later. And also there's a link right here with the YouTube recording of this stream, as well as the timestamp to when we did it. So a lot of cool shit. Hope that helps, Anthony. Great.
That's dope.
Okay, cool. Let's go see what the next question is. Yeah? Okay. I'm gonna do that. So let's see what the chances are so far, right? I love this. I love this is now like a game. So Gladiator has a 50% chance. Let's see who wins. That's the current chances. And looks like, yeah, Gladiator's gonna get picked. Okay, good. All right, Gladiator, you're next. Let's do your question. Get rid of that. We're turning education into gambling? Yes, except like, dude, I mean, all education is, it's statistics, right? Thank you, Potato, for that phallic comment. Jesus. I'm glad you can put like ASCII porn into the chat. But please don't get me banned. Prefer not to. Okay. All right, let's see. Okay. Which one did you need help with, by the way, Gladiator? One and four? Okay, cool. Let me see if I got one here. Okay, find the values of A and B so that the limit is true. Oh, wow, okay. All right, let's go do that. Okay. I need the limit as x approaches infinity of this whole thing to be equal to 0. Ooh, interesting. Oh. I think I have to do like some completing the square stuff. You know? Maybe? Alright. Square root of x squared plus x minus ax minus b is equal to 0. Well, yeah, but this is weird, though, because the limit as x approaches infinity of this thing, this is just going to be infinity, right? I see. This will also be infinity. And then, but then this will be just a constant. Okay. Do you think we need to do like, oh man, Gladiator, you're only in like high school. You're in like lower high school though. I don't think you need to do, we could do a Taylor expansion for this, I think, but, I also don't know if like, sorry, I don't know if there is a value of A and B that this can be equal to 0. I can do number 4. What about e to the on both sides? That way the subtraction can then L'Hopital's. That's excessive. I like that though. Okay, fine. Yes. Okay, cool. That's actually a great idea. Let's do that. Okay. So, Fanatic is saying, let's just do e to the on both sides. Let me know if this is legit for your teacher, if they would allow you to do this, because this is kind of cheating. But, or not cheating, but it's very advanced. So when I do e to the a minus b minus c, this is the same thing as e to the a, e to the minus b, e to the minus c. Yeah, I mean, yeah. This is a very cool trick, actually. Yeah, you could also rationalize it, Shush says. Yeah, I guess you could move that over and then divide by both sides. And then just have it's equal to 1, right? Is that another way we could do this? Yeah, actually, I don't even think we need to do the e to the trick, right? Let's just do it this way. That's a cool thing, Fanatic. I do appreciate it though. Let's say we just move that over, because I think this might be a little bit more appropriate for high school level. This is equal to ax plus b, and then what we're gonna do is we're just gonna move this over. So I'm going to get the square root of x squared plus x over ax plus b. Gotta go. Okay. Good to see you, Fanatic. Appreciate you coming by, dude. This is equal to 1. And the limit as x approaches infinity. Very cool. Okay, this is where you can use L'Hopital's rule. Because as x approaches infinity, you get infinity over infinity. Are you allowed to use L'Hopital's rule? Let me know, Gladiator, if you're allowed to. Pretty cool, though. So what that says is we're going to take the limit as... Oh, you learned something on your own. Okay, cool. Well, here's the rule. So if you take the limit of something and you get infinity over infinity, the reason we get infinity over infinity, right, is that infinity squared plus infinity is infinity. And then the square root of infinity is still infinity. And then on the bottom, you have a times infinity plus b. This is also going to be infinity. So you get infinity over infinity. When you have infinity over infinity, you're allowed to take the derivative of the top and the bottom and then do the limit again and see what you get. So, and you can also apply to it. Yeah, you can also apply it when you get 0 over 0. Another great way. Which, yeah, that works as well. So, if I take the derivative, and this is where, this is cool. This is the exact chain rule that Anthony was talking about. So this is x squared plus x to the 1/2. And then this is ddx of ax plus b. I teach mainly, I mean, professionally, I teach at the college level. This is high school. So the derivative of this, look at this. This is the same chain. This is so fun because look, math is all related. Like we literally just did this shit, right? We just did like derivatives of square roots. This is a chain rule, right? So I pretend this doesn't exist. And that gets me 1/2 x squared plus x to the negative 1/2. And then times the derivative of what's inside. And that's going to be 2x plus 1. And then this is all over this, which the derivative of ax is just a. And derivative of b is 0. Okay? So this is like plus 0. And this all has to equal 1 still, right? So let's try to make this a little nicer. So I get 2x plus 1 all over, and then the 1/2, I'm going to say this is like 2 times a, right? I'm going to do that. And then this also is going to go on the bottom. And so then this will be x squared plus x to the negative 1/2. And this is all equal to 1. You got b is equal to 1/2? I'm curious why b needs equal 1/2. Does it? Sorry, positive 1/2. Thank you. Yep. Thank you. Okay, so this is also now infinity over infinity, though, right? Because this becomes infinity and this is infinity. Yeah? So I feel like I have to take another derivative. Right? It's like, pull the lever again. What does that get us? That gets us 2. Another one. Yeah, derivative of this is just 2. Derivative of this, so 2a is a multiplicative constant. It stays out front. And then you have 1/2 x squared plus x to the minus 1/2 on the bottom. So it's going to go back up top. And then this is also... times 2x plus 1. Wait, I feel like this is just gonna... This is like a nightmare. What?
Disqualified.
Oh, wait a minute. Nope. I have this wrong. Yeah, and also let's rewrite this the right way. Try the binomial expression for the square root. Yeah. This is 2x plus 1 over 2a. And then this would be x squared plus x. No, I need it on the bottom actually, don't I? Yeah. This just becomes the same thing, unfortunately. Because this is 2, and then this is 2a, and then this is 1/2 x squared plus x to the minus 1/2, and then times 2x. So then this cancels. Sure. But then you get... Oh, and then this cancels at least. So then you get x... So then you get x squared plus x all to the 1/2 all over 2a. All over 2ax, sorry. Actually, no, not over 2a. Just over ax. Yeah, this is going to keep oscillating back and forth. Yeah, let's try that. What if you factor stuff in the square root? You can say the fraction part approaches 0. You got to be careful about that. You can't. So infinity times 1 over infinity. This is not 0. I know the 1 over infinity is technically 0. It approaches 0, but it's not. It's not when it's 0 times infinity. Okay. Just in the interest of time, because I know you have another one. Let me just throw this at chat real quick. I just want to see if chat has like some inspiration for me. Someone said they got 1/2 and 1. You use the binomial expansion. Yeah, I don't know if I want to use it. Let me see if chat says to use the binomial expansion, then I will trust it. All right, sorry. Yeah. Okay, it does use the binomial expansion. Okay, that's kind of cheating though, but sure. You would not do this in high school.
Surprise, motherfucker.
Maybe in college you would do this. But here, I'm just gonna post this one. So this ended up like not working. 67 joules. Thank you, DM. Yeah. So this is what we call a dead end. Dead end. You didn't even have calculus in high school? Oh, okay. This is correct. So what they say is you can rewrite this by pulling out the x. And then this is a series expansion. And then if x is large, you just match by term, right? So then that means, what is it? Right. 1 minus a times x plus 1/2 minus b. Wait, where are they getting the 1/2 minus b? Oh, that's from this. Oh, okay. Yeah, okay. I see what they say. So they say x plus 1/2 is equal to ax minus b. So they rewrite this as the first two terms, I think. And then they say, okay, well, what's in front of the x? Well, that's a 1. So a equals 1. What's in front of the not x? That's a 1/2. So b must be equal to, sorry, this is plus b, so b equals 1/2. Yeah, the coefficients have to be the same. And then you assume that if x is large enough, these other terms go away. Which, yes, because x is approaching infinity. Oh, okay, yes. Okay, this is cool. Yeah. We know x is large because x is approaching infinity in the limit. That's cool. Yeah, I was hoping there was a way to do it without doing the series expansion, but I guess we needed it, unfortunately. Okay. And then here, let's quickly do 4. It's cool that I can now see a timer. His answer was correct, yeah. Oh, sorry, where is it? Here it is. Yeah. Let's do this one real quick. I think he did. Yeah, so series expansion works. We'll just write this. We'll say series expansion works. Okay. Is this going to be another series expansion? How many series will I learn next semester? What class are you going into? I wonder if I want to write this out. Limit as x approaches 1. Okay, so if you plug 1 in, you get 1 minus 1, which is 0. Wait, so the answer to this is just 0. Right? Oh, no, because the cube root of 8 is 2.
Surprise, motherfucker.
Damn. Fuck. Okay, that doesn't work.
You done messed up, Aaron.
Oh. Okay. I wonder if I want to do the expansion, or if I don't want to do it. Because, all right, if we did And also, okay, L'Hopital's rule only works when the limit approaches infinity. This is the limit as x approaches 1, right? I think that's the rule with L'Hopital's rule, right? I think it has to be as x approaches infinity. You can make it look like that. Oh, no, actually, sorry, it doesn't have to approach infinity. Yeah, you're right. I think as long as it's in this case, it's 0 over 0. You're right, Psychode, yeah. Only expression, yeah. 0 over 0. So we could. So if we took the derivative of this, so this is x to the 1/4, effectively, right? Over 3x plus 5 to the 1/3. Because when I take the derivative, I don't really care about these parts. So the derivative of that would be 1/4 x to the negative 3/4. What's up, Bella? And then this would be 1/3 3x plus 5 to the negative 2/3. Which as x approaches 1, I feel like this is okay now, right? I think we're cool, right? Because nothing's gonna like hurt us, yeah? Right? So this is just 1/4 times 1 over 1/3 times 8 to the negative 2/3. But then the 1/3 root, so the cube root of 8 is 2. So this is 1/4 over 1/3 times 2 to the negative 2. So then this is going to become 4 on top times 1/4, which is going to cancel, become 1. And then this is over 1/3 on the bottom, right? So I think the answer is just 3. Did chat say the answer is also just 3 for you? Pretty sure it would be. Wait. Oh. Okay, wait. The bottom one is a cubed root. It thought the bottom one was a square root.
You done messed up, AA
Which I thought
Ron.
at first too. Right? Yeah, this is 0 over 0. Use L'Hopital's. Cool. Evaluate at 1. I think the answer is 1. Did I get 1? No. I got a third. How did I get a third? How did I get a third and they didn't? Oh, you... No. One sec. Oh, you know where I fucked up? I gotta do this times 3. Times the derivative of what's inside. Sorry, so that would cancel. Okay, now I'll get 1. Yeah, now the answer is 1. There we go. Nice. There we go. Cool. Good job. I missed the chain rule. No. The one thing we were teaching today.
Well done.
All right, nice. That was Gladiators. Done in 20 minutes. That was cool. Yeah, I like having a timer to now see where we're at. I can understand how much time it's taking. 20 minutes per question is not bad. A little on the longer side. All right. For a minute, I was really impressed with how fast you derived it, but you ruined it. I'm sorry. I did, yeah. Okay, let's see. What's the next question on... we don't need to spin. Okay, here we go. All right, so current set of questions looks like kind of an even 3-way split on the top 3. So let's spin. So who's gonna win? Looks like it's gonna go to Harvey. Nice. Good job, Harvey.
That's dope.
Cool. All right, Harvey. Let's do your question. Remember, if you really want your question to be answered, you can always upvote it every 3 minutes in the queue. Cool little gaming thing we have. So if you really like your question here, so for instance, like let's see Cowboy. Cowboy's asking for the impulse responsive system. Oh no.
Huh?
This would be scary. But let's say I just like pain. I could go over here and click upvote, and then Cowboy would get a boost to the amount of votes. So if you see something you like, give it some more votes. Okay, let me see if I can do this. You know what's also fun here? There's also a me first on, within Twitch. I haven't made that automatic yet, but that would be cool. I'm selling me first redeems $2. Yeah. Well, it's also to like reward. Like people should watch on Twitch. Twitch is great. Okay, let's see. Functions f, g, and h are differentiable on some open interval around 0 and satisfy the equations and the initial conditions. Find an explicit formula for f of x valid in some open interval around 0. Oh, and let me give you points, Gladiator. My bad. I forgot. Cool question, though. Yeah, I see that. Cool. Is this like a potential function? Because look, so I feel like this is this. Right? We're saying that like grad phi is equal to like f maybe? I don't know. I kind of see something here, right? This looks like something plus d, like a function of g and h. D prime maybe? Or dt? I think these are like dt. Yeah, I think f prime is with... Okay. Yes. Okay. Here's a cool thing. They're all dependent on x. Oh, this is beautiful actually. Oh, I think I understand this now. Okay. So we say that df dx is equal to 2f squared gh plus 1 over gh. Okay. And then we're going to say that like dg dx is equal to f g squared h plus 4 over fh. Is this the physics of calculus? It's kind of cool, actually. And then this is... I just see... I feel like it's a potential question. Because notice how every, like, last bit here doesn't depend on the other variable, right? See how this is g and h, this is f and h, and this is f and g? That's exactly how finding potential functions works. What I don't like is that this is different in every case. But maybe that has to do with this h of 0, f of 0, blah, blah, of 0. Use the initial conditions. Oh, beautiful, actually. Yeah. Yes, you're right. You were so right here. Thank you, Shush. Okay. Yeah, f of 0, and that's why. That's why, look. So f of 0 is equal to 1. So if we were to evaluate this. Watch. Let's evaluate this at x equals 0. All right? I know that f of 0 is equal to 1. So this would become 1, right? And I would just get 2gh plus 1 over gh. So what is that? So 2g squared h squared plus 1 over gh is equal to df dx. I don't know. How does that help me, though? I wish it was equal to 0. That would help me out here a lot. I don't want to be equal to 1. G and H are also G. Oh, okay. Oh, interesting. G and H are also 1. Correct. Yes. Yeah. No, you are right. They're all equal to 1. Oh, okay. Wait. So this would be then 2 plus 1 over 1. So that would be 3. Okay. Yeah. Okay. Uh-huh. Okay, so then dg dx at x equals 0. Write an explicit formula for f. I think you mean for capital F, right? Oh, they mean... Oh, the question is saying just an expression for f. Oh, wait a minute. This is equal to 5? Yeah, let's see. And then dg dh at x equals 0 is equal to 4, right? That's what I get if I plug in 1 for all these. Yeah, can I just move the dx over? Can I really do that? I feel like that's illegal. I think what I end up getting there, right, is f is equal to 3x plus c. Or plus c of like g and h, basically, right? Oh. No. Yeah, no, that doesn't really work, right?
You done messed up, Aaron!
Alright, consider big F is equal to... Yeah, alright, let's do that. Let's do that. What's up, video games? I'm getting wrecked by, I think this is PDs. Alright, let's again, I wanted this to, like, kind of happen. I wanted some, like, grad F equals F. That's what I want. I want this. I want this to happen. Shush says, let's consider that F is equal to little f gh. Right? Okay. But then what do I do with that? I'm a little confused. Alright, let me see. Let's see if chat can give me some inspo. Come on, differentiate it. Oh, you mean just do the product rule? Okay. Alright, let's hold the phone. Hold the phone on ChatGPT. Let's try this. Okay. Alright, we're just gonna assume this because Shush in my TikTok chat said, like, let's just assume this. Alright. Then f prime is equal to f prime gh plus, I want to say, g prime fg plus h prime fh. Stop. Hold the phone. Stop the phone. Yeah.
Huh?
Okay. Cool. What does that tell me, though? Oh. Do you want me to, like, plug these in and see what happens? Simplify each term, he says. Okay, well, okay, so f prime is equal to this whole thing. So that's 2f squared. So that's 2f squared gh plus 1 over gh times gh plus fg squared h plus 4 over fh. Sorry, this should be fh, not fg. This should be fg. Thank you. FH, and then plus 3FGH squared plus 1 over FG. All right, let's do it. Let's do it. Times FG. Okay. So here's a cool thing. GH comes through, cancels that. And so then I'm given 2F squared G squared H squared plus 1 plus... Oh, this is cool. This is going to square this. This is going to square this. So then I get plus... F squared G squared H squared plus 4 plus 3 F squared G squared H squared plus 1. And this is all equal to F, big F prime. And so what is that? That's 6 F squared G squared H squared plus 6 is equal to big F prime. Uh-huh. Oh. So then, wait. Can I take this and, like, just plug it back into there? No, because then, wait, I still have an F squared. Multivariable derivative.
You done messed up, Aaron!
What's up, Zach? Solve the differential equation for f. Okay, sure. Well, that's just gonna be 6 f squared g squared h squared x plus 6x is equal to f. Presumably, right? Oh. Wait a minute. Uh-huh. Oh, this is beautiful. Okay. But then f was also equal to fgh. Right? What's this vote queue? It involves evil probability. It's a way for you to decide who gets vote. Okay, wait. So then 6fghx plus 6x over fgh equals 1. I don't like this. Okay. Yeah, I understand that. But wait, where'd the x go? I think there's still an x in there, no? For here, right? Didn't I have to pop an x when I integrate both sides? Right? Okay. All right. I'm getting there, dude. Okay, but f squared equals... Okay, so what? You get 6. Don't integrate yet. Okay. All right, let's not integrate yet. Okay, fine. Okay, here we go. But f squared equals that. So you get 6 big F squared plus 6 is equal to f prime. Okay. And then, what do you want to do? You want to do f prime minus 6f squared minus 6 is equal to 0? And then, do I say f is of the form e to the ax? So then this is a... Oh, well, that doesn't really work, does it? No. Yes. I got that too. That's what I got here, shush. Think you want a full quadratic here. E to the ax squared plus bx plus c. Oh, wow. I see what you're saying. Like that? So then f prime? Dude, this sucks, dude. What?
This
Oh shit, not good.
This is getting really bad. How many minutes have I been working on this question? 15. Okay, we're getting close. I think I'll cap things at 20. Go back, separate the variables, and integrate. I don't want to.
Surprise, motherfucker.
I don't want to. Oh man. Okay. All right. Okay. Let's see what chat said. I want to see what chat said. Okay. Chat agreed with this, right? F prime is equal to 6f squared plus 1. 6. Yeah, that's what we got. Yeah, Jeff. Sorry, Zach. Don't you like it? Isn't it really cool? Chat says you shouldn't vibe code.
Bruh. You done messed up, Aaron.
I'll show you, Zach, when we finish this question, how the system works. But it's because we were getting too many questions asked during streams, and I want to make things, at least I want to make it so that if you ask a question and the queue's still long, you still have a chance of getting your question answered. Okay, let me just see what they do here. Arctan. Oh no, this is getting bad. Okay, yeah, sorry. All right, Harvey, for the sake of just time to make sure I can help out everybody else, we got to here. I'm cool with that. I don't know about this last part. This looks really messy. But I invite you to take a look at it, and I'll put it in my server if people want to discuss it later. But what class was this for, Harvey, by the way? Is this partial differential equations? Yeah, they did want the 6th root of secant. Yeah, but I don't think I was gonna get that. Oh no, dude. Oh no.
Oh no! Oh no! No, no!
Oh, it's a Putnam question? Dude, what? Dude, of course it's gonna... Alright, this is me really... Okay, yeah, great. Yay! High Potential says, don't listen to him, vibe everything, no critical thinking is left. The shareholder is all that matters. Long live the token! What's up, High Potential, dude? I will say, dude, I recently got on the Codex 5.3 CLI game these days. Just because, man, it is so powerful. Token price go up. Yeah. It's super rad, like, what you can code. Again, I would love to have the time in my life to do this myself, and I really respect Zach for doing it himself, but I just don't. And I am kind of a believer of, what is it? Function over form? Except when it's gold clothing, because none of my gold clothing is functional. Water go down, humans starve. Yeah, exactly. Anyways. Cool. The reason why, Zach, so let me show you. This is the new system that got built in. I built this yesterday. I built all of this yesterday just because I was able to burn through a bunch of water bottles and tokens. But I identified a problem we're having during streams, which is people ask a lot of questions at the beginning of the stream. Then they see the queue is like 7-8 questions long. And then they check out because they're like, I don't want to ask a question because there's no fucking way he's going to answer it in the next 2 hours. And I don't want to wait for 2 hours. And so I agree. You know, that kind of sucks. And then what happens is people are engaged at the beginning, but then when I start getting to the later questions, those people have left because they didn't think I was ever going to get to them. So you want to give people false hope. Yeah. So I don't know if it's false hope, and we can tweak this. We can tweak this in the future. But so what I want to have happen, and again, this is also my metaphor in everything we do in the server in terms of prizes and things. Just because you're first doesn't mean you always win, and just because you're last doesn't mean you always lose. Life is kind of random at times. You increase your chances by being better at stuff, 100%. But at the end of the day, I don't want people to give up just because they're not, first, or in this case, high up in the tier. You've noticed that problem? Right, so this is my solution. I came up with this in the shower, and then I thought this was really cool, so I was dreading doing it because I knew it would be a coding nightmare for me to do. And then my friend showed me Codex and like Claude Code, and I did this in an afternoon. Great. Thank you, P. Diddy, for submitting something. What did you submit, P. Diddy? Okay, you submitted something legit. Okay. What's the point of working hard to get first? The point of working hard is you have the best chance of winning if you're first. 100%. I believe hard work should always be rewarded. If you do good, you increase your chances of like luck hitting you. 100%. But I don't think you should be excluded from ever winning just because you weren't first. Or in this case, you didn't like... So your message, no, but there's no purchasing here. So yes, how do you purchase a better chance of your question getting asked? If you stay active during the streams, which means you're watching us solve other people's questions, you're listening in, you're tuning in or whatever, you can still vote for your question every 3 minutes. So if I see like somebody's question, or if you in the crowd see someone's question you really like Jacob's, I think Jacob's is cool, you can go here and you can upvote it. And that will give it a boost to its votes. We'll simply clone Dr. Gold and remove the competitive market. Yeah, maybe. So anyways, submit a question. If you submit your question sooner, it accumulates more votes. So again, if you got here early, you have a better chance of your question getting asked. But here's the funny thing, like DM Scrader submitted his question before the stream even started, so he was technically the first person. I will clear that in future things. You can't submit before the stream starts. But his question hasn't been picked yet because the random chance gods have chosen other people. Yeah. Dr. Platinum, Dr. Copper, Dr. Brass, and Dr. Silver, yeah. So, yeah. Even if you submit a question towards the end of the stream, you still have hope. In this case, P. Diddy has a 0.7% chance of getting picked. It could happen. What I'm going to do is I'm going to mark that one is done. And then we're gonna spin the wheel for who the next person is. Wow, thanks, High Potential.
That's dope.
Round numbers only, dude.
Potential just donated $1.57 to
love it, High Potential, dude. Hope things are going well. All right, so this was whose question was this? This was Harvey. Spin it 5 times to see if there's bias. It's pretty random. I'm pretty sure. I don't have an option to keep spinning it. But 1.57 is approximately 2. It is. Yeah. Thank you. Appreciate it. Okay, so yeah, let me choose the next winner. Here it goes. It's spinning. Who is it gonna go to? In this case, it's Cowboy. All right, Cowboy. You're next. DM Scrader's like, God damn it, like I submitted first. How have I still not been picked yet? Your old therapist's name was Dr. Pepper? Do they also have like 23 flavors? Alright, let me see, Cowboy. Okay. I also may like not be able to do this question because this looks a little difficult. Okay, it says, okay, a casual LTI system has an input-output relation given by this. Find the impulse response of the system. I have no clue what this means. You can do this one? Okay, Zach, do you want to help? I don't know what impulse response is. Is that like y of x equals x of t or something? Okay. Do you want to hop in my server and like talk? Laid back LTI. This is y of t equals h of t and x of t equals delta t. What is the goal mathematically? Well, okay, maybe let me Google like what LTI system is. Linear time invariant is a model used in engineering and physics that processes input signals based on two properties, linearity and time invariance. Okay. You're almost faster than Google. We need to get Zach AI going. Okay. Oh, and there's convolution in this. Okay, that's cool. Uh-huh. Okay. What are we solving for? Angel says this is y of t is equal to h of t, and x of t is equal to, sorry, delta of t? And, I mean, what I saw here, right, is that x of t goes through some h of t thing and then outputs a y of t. Okay, so y of t equals h of t. That makes sense. Delta t is the impulse function. Oh, okay. Impulse in physics usually means, like, a sudden, like, hit or something. This is not E&M. No, this is signal analysis. Video games wizard. But it's with differential equations. Yeah, so I guess impulse here is like maybe the delay that hits. So you want to know that, like, if the delay is this, like, how does that affect y of t maybe? I'm thinking that's how it works. Okay, but how do you solve for it? Yeah, okay, so input signal, Laplace transform. Okay, cool. Okay, we can Laplace transform. Let me remember what my Laplace transforms are, though. Uh-huh. Well, I want one of these nice tables. Yeah, I feel like this is the one I want. Yeah, but there's something for the derivative one, right? Wait. How do you do? Oh, here we go. This is it. Right. Okay. Make a video serving all Laplace transforms. Okay, this is it. So when you take the first derivative, that's s to the n f of s, where f of s, I think, is the Laplace transform of whatever your function is. Oh, okay, but we don't know what f is. Okay. I think I got this. Okay. So, but then what's the Laplace transform of just the function? Oh, it's just f of s then, no? Okay. Maybe let's call this one, like, I don't like the f's and s's. I'm gonna call this like capital Y. I'm gonna call this one like capital X maybe, or like squiggly X. So this one, the second derivative, I know is s squared capital Y, right? Of s. What's up, Gladiator? I do need to. Oh, it's a Dirac delta. Oh, yes. Dirac delta functions are 0 everywhere, but infinity when t equals 0. Got it. Okay. So that's that. That's the second derivative one. The regular function, I think, is just... So here, let's write this out like formally. Laplace of y double prime of t is equal to this. The Laplace of y of t is just equal to big capital Y. That's wrong? This one isn't right? I think it is. Second derivative, right? S squared f of s, and then this would be, oh, s f of 0. All right, my bad. I need ICs. Okay. All right, s y of 0, right? S to the first, y of 0, do we agree with this? And then minus y prime of 0. Y double prime, I think you mean, right? Not y x prime? On God, autocorrect. Oh, okay. Yes, got you. Okay, and then, so for y of t, that's just y of s, right? And then the Laplace transform for x of t is just going to be capital X of s, right? And then the Dirac delta one Zach gave us. Oh, this is a mess. Oh, Jesus. What is it? Oh, I passed it. Okay. Oh, so it's just S? Or it's delta t. I was on it. It is just S. Okay, cool, great. Okay, awesome. Oh, okay. Oh wait, so this, because we said, well, one second, let me just write, because we haven't said it's a delta function yet. Let's just get the derivatives at least right. Okay, and then dx dt. So x prime of t. That's equal to s x of s minus s prime x of 0. Good to see you, Visible. Yeah, right? Cool. We're cool with that so far, I think. Because then I don't think you can have a... Yeah, it doesn't keep going. Cool. All right. Okay, but for a delta function, x of s is just equal to s. Uh-huh. Okay, so what? I just plug everything in? Just see what we get? Negative y of s. Plus all this. Hot mess. Solve for y of s. Okay, cool. But not that. I hate when it copies it twice. Okay. Equals... Let's just leave it as x of s for now, and then I think I'm just gonna like substitute later. X of s minus 2 minus 2s x of s plus 2s prime x of 0. Why are you putting the s? But you know, x of s is equal to 1. I thought x of s was equal to s. Okay, no, this is equal to 1. Okay, cool. So this is 1. Oh, my bad. Sorry. Yep. No. That's S squared. This is S to the 0. Sorry. This is, yep. Thank you. Yep. No, you go. There you go, Red Roach. Sorry, that's what I meant. Okay, good. Okay, cool. All right. I think I got it. X of S equals 1. Okay, cool. So this is equal to 1 minus 2S plus 2x of 0. We agree so far? For the right-hand side? And then this is y of s squared minus 1 minus s prime y of 0. Wait, sorry, is that s prime? Did I have that right? No, it's not s prime. What am I saying s prime for? Sorry. Yeah, it's not s prime. It's just s. Dude, I'm getting my primes and my ones mixed up.
Surprise, motherfucker.
Damn it. Okay. Thank you. Okay. Don't write s to the 1. Yep, don't do it. Don't do it. Not even once. You know why? Because I was just looking at this. And I was like, oh, the nth derivative is the, whatever, the nth derivative of s, but that's not right. Yeah, that's totally not right. Okay. Yeah, Laplace transforms is something I'm still kind of weak in. I haven't done too many of them. Zach is the expert in these for sure. Okay. Nice. Okay, so what? I just solve for y of s? Is that what we do? Come on, Wednesdays. Yes. Oh, by the way, yeah, if you guys are watching, great place. Go check out the streaming schedule. There's a cool little calendar. And looks like, yeah, Zach's doing Diffie Q development. Does that include Laplace transforms? On Wednesday. So go check that out. There's actually a lot of really cool activities we're doing. A lot of stuff. Nice. Mavort's on here too. I've reached out to some other people that Machine Rex said. Okay, cool. All right. What do we do next? I'm tempted. Yeah, but then what about all these like nasty things here? Can I just say these are 0? Can I just get rid of them? Some like initial conditions thing or whatever, right? Can I just assume that they're constants? But can we just assume they're 0, right? At t equals 0? Oh, they're initial conditions? Fuck. I really don't want to deal with them. Okay, fine. Okay. Alright. Y of s is equal to 1 minus 2s all over s squared minus 1. And I'm going to put all the constants over here. Plus 2x of 0 plus s y of 0 plus y prime of 0. Right? Wait. I think the y prime is correct, yeah? Was I allowed to do that? Yes. Okay, the y prime of 0 is okay. That's not y to the first. Okay. And then this is all over s squared minus 1. Yeah? Then my goal is probably to invert this. Right? So Laplace transform is basically take differential like whatever thing, put it into Laplace language, do some algebra, and then convert it back. That's how I think of Laplace transforms. Right? So this is the same. Yeah, I can rewrite this, right? This is 1 minus 2s over... And this is going to be s plus 1. And then this is going to be s minus 1. Yup. And then plus all this hot garbage. What class would this be in? Probably like signals or something. This is partial fractions, no? Let's just do some partial fractions, right? 1 minus 2s is equal to a over s plus 1 plus b over s minus 1. Let's do that, yeah? Constant over s squared plus... Oh, I see what he's saying. Wait. Okay, wait. All right, so wait, before we do this, I see. You're saying that I could have taken... that the 1 is just going to go over here? You want me to say, like, just plus 1? And just say this is minus 2s? And then we'll just, like, deal with all the constant shit later? Okay. I think I want to... You'll come in chat. Thank you. Sorry, I'm struggling.
Oh shit, it's not good.
I'm struggling. Oh, wait. Oh, because we have this? Is this what we're saying? I see. I think this is what he's saying. Yes, because then it's just... Ooh, excellent. I see why that's just cinch. Come to the stage, Zach.
Hey there.
What's going on? Appreciate.
Good job.
Okay, let's take a look. Sorry, I had something in my eye, so I was itching it. Anyway, so you've got... what I would do here is just combine all the s terms and combine all the constants into one fraction. The reason for that is so that you can have those constants pulled out, because we're doing an integral for the Laplace transform, any constants can just be pulled out.
Okay.
So we care really about the structure of the fractions.
Okay, let's do that. So you were cool with me putting my plus 1 over here, but you're saying I should bring this one over?
Yeah, just bring all the constant things, like the plus 2x. So yeah, like that. Yep.
Yeah, and we'll just leave all this stuff over here. Be like, no one wants to play with this stuff.
Yeah.
Okay, cool.
There you go. And those are all just be constants that pulled out at the end.
Gotcha.
So that you've got cosh times that constant. Sorry, I'm going too fast.
No, you're okay.
I don't want to go too fast.
Where's the cosh coming? Is the cosh coming from this?
So the cosh, it's coming from the denominator. The fact that we have a minus sign, look at your table.
Yeah, I'm looking.
It's cosh on the right side. Right side. Right column.
Oh, yeah. Oh, beautiful. Oh, very cool. Oh, and then one of them is cinch or something.
Yep.
I'm just going to
Yep, one of it. So you're going to have a cinch and a cosh in there.
Okay, cool. Let me do that.
So basically, this is cinch times whatever your constant is, plus cosh times whatever the constant is. And that sort of makes sense because cinch and cosh are e
Signaling
to
things.
the... Yeah, they're e to the x and e to the minus x. They're...
Got you.
That's how you define cinch and cosh, is the sum and difference of...
So we're not even going to partial
that.
fractions. We can just leave this like this, right? And then I see this is...
Well, if you did the partial fractions, you'd end up with e to the x and e to the minus x, which is what cinch and cosh actually are anyway, so why bother?
Got you. Why bother?
You could do it. You could do that, but it's no...
It's just extra work. Okay, so there we go.
It's
So
just
this
extra
is what I have. Okay, so this will turn into like... Yeah, I get it. That one will turn into cosh and cosh.
Even better, just factor out the s and treat it as one...
Oh, yeah. I like that. That's even better. Yeah, I get what you're saying. Let's say this is negative 2 plus y0 all times s. Right? All times s over s squared minus 1.
That's right. Yeah. Yep.
Perfect. Okay.
And that'll be cosh of t. Right?
Okay. So that would be y of s. So then y of t would be doing the inverse.
You have the constant. Yep.
Okay, so that becomes -2 plus y of 0, and then this part becomes cosh of t, right? Perfect, cool.
Yep.
Okay, and then all
you've
this
got
stuff
the other
becomes
one.
sinh.
So you can again factor out that constant. The
Which, yeah, the
numerator
whole
is
thing.
all.
It's all
the
a
whole
constant.
thing is just a constant.
Yeah. Okay. Ooh, this is cool. Okay, +1, and then this is times the sinh of t.
You got it.
Okay. And then we're done.
That should be it. Yeah. The way you check
nice.
that is just if you're, I guess, if the derivatives check out, you can put it in GPT if you like. I guess.
Just don't do it. Here, yeah.
Put it in GPT because you should, right? Like that's what you're gonna do anyway. You may as well.
Let's just see what GPT did. Let's just see. I just want to see what happens.
It probably did it differently.
I liked your way though. Let's see. Your way made sense. What class would this be like a digital systems class, right, or something?
It'd be a signals and systems class for engineering.
Okay, let's see. Yo, what? Making a transfer function? What's it doing with a transfer function?
Oh, they did get rid of the other. They have 0.
Oh,
okay,
0.
so it assumed 0 initial conditions, which is fine, I guess.
Okay.
We solved the general version, but if you, like you said, you could have, I suppose, if you take 0 initial conditions, that's sometimes
is that just because that's how systems work, I guess?
That's just an oversimplifying assumption, but this works.
Okay, they did partial fractions, which is what I was thinking about doing. Okay, so it's not gonna be on your plate, don't worry. And then, okay, 1/2 e to the t plus 3 e to the minus t u of t.
That is...
is that sinh plus
They're
cosh?
doing it... Well, we did it using sinh and cosh. GPT's using... We'd have to go check all that. It, I think, works out the same.
Yeah. Curious where the 3 would come from, though.
Well, okay, so if you want to check this, we need to set all the y of t, y and y naught should be 0.
Okay.
Right, so let's actually verify.
So this is 0, this is 0, this is 0.
Those are 0. We'd get... So the way this would be written is... Yeah, write that down. And then...
Plus sinh of t, that's it, right?
Right. The definition of sinh of t is e to the minus t, or e to the t minus e to the minus t all over 2.
Okay, beautiful. Oh, so then this would be the... Is this the plus one?
It's the plus version, yep. So you get -2 of those, and that probably will do it. Over 2. Yep.
Okay, let's see. And this
So
is
you
plus.
add those.
So negative... this goes away, right? I see. Okay, so I get 3/2 e to the t, and then plus 1/2.
Hold it. Wait. Minus 1/2 e to the t, because you have a minus sign.
Oh, there's a minus sign here.
That's right. Yeah, so it's minus a half. Yeah.
So many bad things. Okay, let's put the minus there.
No. Okay. Yeah, you can do it that way if you like.
No. I agree.
Commutativity is a thing, right?
Yeah. Okay, this is minus e to the t plus 1/2, so that's minus 1/2 e to the t, right? And then this is minus e to the t minus another minus e to the minus t minus another half e to the minus t, so that's minus 3/2 e to the minus t.
And there you go.
And there we go. That is the same thing. Wow. We did it. Good job, Zach.
For you too. You did it.
Angel says, "Oh damn, our class did it completely differently. It just replaced x of t with delta t and y of t to h of t." Yeah. So I mean, it's a signals class, so they probably don't go as in depth as Zach did, because Zach's a math god and like knows the actual underlying formulation of this stuff. I feel like a lot of engineering classes just put band-aids on things, and they're just like, this is the safe way to do it.
I've actually had professors. There's a time where I taught differential equations at the college level, and my I had I had students in the class who their engineering professor says they just run them over. They run them over with stuff and say, "You're just good luck, kid. You're gonna have to figure it out." So it's true. Like for engineer students, that happens more often than not, I think.
You just get steamrolled. I hate the hand waving. It's the worst thing in education.
Yeah.
Okay.
Oh, well.
Nice. I really appreciate that.
Now you know.
Now I know. Yeah. And I feel like I know a lot more now. Wait, how has Big Cars gotten more votes than anybody else? Wait, has someone really been like spamming the votes on my system? Has someone found a way to hack it?
Is it GPT? Oh,
yeah.
Is it Claude? Is it Codex?
It's actually a combination. I ran out of Claude credits, and so then I switched this over to Codex mid coding.
That's
Codex
how they're
finish it.
That's how they're gonna get you, Gold. That's how they're gonna get you with the credits.
This is so funny. They actually do and
actually, isn't this turning into the Empire from
yes,
Star Wars?
Andor's correct. It's all Andor. We don't take Codex credits here. Your cloud credits are useless on Naboo.
Just wait. Just you wait, okay?
I know. It's our I'm just here for the downfall party. It's gonna be fun. But no. So this brings. I have a gaming mechanic with the questions. So with the cues and the questions, where like if they hit upvote, it'll add 25% of what their current votes are. So it is technically kind of exponential, right? If someone is on it and just like keeps hitting it every 3 minutes, they would surpass the naturally increasing timer.
Wait, so is it an exponential increase? Like if you get exponentially more points the more you do it?
It's I think it's 1.15 maybe. Sorry, I think it's a 15% boost every time you do it. So if someone is really hammering it, right, that would be exponential growth. Whereas,
that's true.
Whereas, so this is a great thing. Wow, there's even math in the gambling system of our question system. Because the other way it accumulates votes if you don't touch it is it's linear because it's only the amount of time it takes. I think it's like 2 points per minute or something.
That's that's an interesting system.
Isn't it cool?
Yeah, it is.
I came up with.
I'm impressed. Yeah.
Thank you. Well, I only came up with the lottery idea in the shower, and then I went to Claude and I said, "Here's my idea. Come up with I want some gaming mechanics so that it doesn't punish people too much if they join late, but it also rewards people if they got here early." And this is the math it came up with, and I was like, "That sounds pretty cool."
Yeah, that's interesting.
Yeah.
I want to see how it goes. Just like anything, you should play test it. See how it works.
That's what we're doing. We're play testing it today. Just like we'll be play testing the exhibition match of 16 coming up in a couple weeks.
Oh,
right?
Yeah, that's right. We're doing that in about 3 weeks, and you're going to be our MC. I'm developing stuff for you, and I'm excited to see how if the tools work. They seem to be working. Yeah, it's gonna be fun.
Super hyped. I'm gonna start writing my questions today because we're meeting I think next week, right, for the questions.
We are meeting next week, yes, and
perfect.
Get excited for Pi Day. That's the hope. Assuming everything goes to plan, I'll give you more information. We'll pass out flyers and stuff and get the word out there.
I'm down for it. We'll hype people up. Sick. All right, awesome. Thanks, Zach. I appreciate that. Let's pick another winner. I got 15 minutes left. Who's going to win? Spin, spin, spin. Who's going to win for the next question? Blue's been waiting all day here, dude. But I feel like the gods have spoken. It's Jacob. All right, Blue, don't worry. I will do your question regardless of what's happening next because I can't do that. The new queue system is actually pretty cool. Thank you, Gladiator. Yeah, I think it's pretty cool too. But, you know, I saw a problem. My problem was that we're getting too many people, which isn't really a problem. It's a great thing. It's a great problem to have. But I wanted to make a way so that it's still so that we solve the issue of people getting bored or people getting discouraged. My luck has spread to office hours. Yeah, what's up? Pineapple, you can still ask a question. It's just whether I get to it in the amount of time we have left is up to the probability gods. But you do have a chance. You always have a chance. All right. Let me see this one. A golf ball is struck and leaves the ground at 43 meters per second on a 60-degree angle. How long will it be in the air before bouncing? Cool. There's a fun equation for this one. It's just kinematics, right? So, y equals y naught plus v naught t plus 1/2 at squared. And in this case, v naught is specifically only in the y direction. So v naught y is going to be, I can't really read that. I think that says 43. So that's going to be 43 sine of 60 degrees. How much time is left? There's 13 minutes left. Yeah, and then I do have to go. But don't worry, we're streaming Thursday as well. Maybe I should do a stream on Wednesday, because I know we didn't stream on Monday. All right. Cool. So then this is 0 equals, this is 0, and then this is plus 43 sine of 60 degrees, which I should have in a calculator somewhere. And here, I'll probably do a couple parts of these. I don't know if I'll have time to do all of it, just because I want to help out Blue, for sure. Blue's been waiting the whole time, and just hasn't gotten lucky with the thing. Okay, so that's 37.24. So then this is going to be 37.24 t, and then this becomes minus 4.9 t squared. So now you can move that over. So you get 4.9 t squared, and you can also divide by t. 4.9 t is equal to 37.24. So you get that t is equal to 7.6 seconds. Oh, we don't need the Q system. Okay, so there you go. T equals 7.67. 7.6 seconds. How far will the ball travel in the air before? So this is a good question. Are they talking about like in just y? Like, usually this means like x displacement. And so delta x in this case would be equal to v naught x times t. Because there is no acceleration in the x direction. So it's just the velocity in the x direction at the start, which doesn't change, times the amount of time it's in the air. So this would be equal to 43 cosine of 60 degrees times 7.6, which cosine of 60 is 1/2. So that times 43 over 2, it's going to be equal to 163 meters. Great. The overall velocity of the ball is a tangent vector. It consists of that. Determine the velocity vector at the highest point. Very cool. So right, it has always y components and x components. So at its highest point, it's no longer going up anymore. So velocity is strictly to the right. And then once it starts falling down, you start getting more velocity in the down direction. So now this arrow shifts down a little bit, and it should look the same as this, just opposite direction. What's the maximum height reached by the ball? So here's a cool thing. You can say if start and finish are equal to 0, like if the height starting and the height finishing are 0, then the maximum height also occurs at like the halfway point. So if you want to solve for that height, you can just do this. You can just say, okay, y is equal to 0, and then that would be plus v naught y times the half time, so 7.6 divided by 2, and then minus 4.9, 7.6 over 2 squared. Reason for that, it takes a full 7.6 seconds to get from here to here. And if in physics, if you start here and you end here, if you start on the ground and you end on the ground, your maximum height will occur halfway through your trajectory, which is nice. Okay, cool. Determine the velocity of the ball 2 seconds after it's struck. Okay. And then 2 seconds into the flight. So 2 seconds into the flight would be here. You can pineapple for sure, yeah. Yes. So, yeah, all of this can be done with conservation of energy as well, but a lot of students, they're told they have to just use mechanics for this, and then they learn conservation of energy, and then it's like a whole thing. It's like, oh, wow, this could have been solved so much easier if I just used conservation of energy. We could just do that. Yeah, let's just to make things quick, just so I have time to help Blue. Let's use conservation of energy. So, kinetic energy at the start is equal to 1/2 m, and then v squared is just going to be the full 43 squared. And then potential energy at the start is equal to 0 because it's on the ground. And then after some amount of time, kinetic energy at 2 seconds, that's going to be 1/2 m. We're going to solve for v squared. And then the potential energy at 2 seconds is equal to mgh, so that's mg. Oh, now we need the height of the ball after 2 seconds, though. Man. I gotta go I still gotta go plug it in anyways. That's annoying. It doesn't help you too much. You picked the only problem where it's harder? Yeah, I did. Okay, so actually we don't want to do that. Take it back. Take it back. Take it back. Alright, fine. I thought it would be easier. The problem is they gave us 2 seconds. Okay, so this is what we have to do. So Vy is equal to V0y plus AT. So that's going to be 43 sine of 60 degrees minus 4.9 times 2. And then Vx is going to be the same 43 cosine of 60 degrees. So let's do that. 43 sine of 60. Was that? Minus 9.8. So that gets us 27.4 meters per second. This gives us 21.5, right? And so then the total energy is the square root of those squared. That's summed up. So what is that? So that squared plus 21.5 squared, square root it, and you get 34.85. Nice.
Yeah.
And it says the most common incorrect answer is 22. What actually was calculated? Well, 22 was just Vx. It was just the velocity in the x component. Didn't include Vy. That's why they messed up. Okay, cool. Totally makes sense, Jacob. 22. I'm feeling 22.
Good job.
Yes. All right, let's mark that as done. Cool question, Jacob. All right, Blue, I'm gonna help you, and then I want to roll the thing afterwards to see. I'm confused how you somehow missed out getting picked. I want to make sure that's not a bug in the code. That like first can't win. So this isn't Blue. Sorry, this is. There you go. All right, let's see. Because yeah, big cards. Codex, anyone?
Alright, motherfucker.
All right, here. I'm gonna help Blue. What's up, Haunted? Don't worry, we're gonna still be streaming on Thursday. AI never made mistakes ever. All right, Boo, let's help you out. The number of followers an influencer has on social media is as below. Dang, this person started selling feet pics or something. Dude. What? That's some massive gains, dude. Write a recursive formula for the number of followers. Okay. So this looks geometric, right? Because it's jumping by a lot. And the difference is not constant, right? This is like 400. This is like 1200. It's like 3K or something. Yeah. So what you want to do then is see if there's a multiplier between these. So you do this divided by this. So let's check out what 630 divided by 210 is. Well, that's equal to 3. Right? And then I think same thing here, right? Look, 1890 over 630 equals 3. If only gross by power of 3 we're so easy. I agree. And this is probably by a factor of 3. So, the formula, right, would then be, let's say, like, followers at some week is equal to 210. And then you would say times 3 to the W minus 1. This is, I think, the correct way to say it. Right? Because at week 1, you get 3 to the 0. 3 to the 0 is just 3. Or is just 1.
Disqualified.
You just get 210. And then every time W goes up, you multiply by another factor of 3. Yeah. That's the correct way to do it. What number does 210 represent? That's like the initial. Or I think usually they call this like A0. Kind of what they call it. And then... Oh, I see. Sorry. This part is this. If they want the recursive formula, you would say that like an plus 1 is equal to 3 times an. And what this means is that your next term, so the next amount of followers, is 3 times what your previous amount was. By this model, 70 was the initial. Yeah. Oh, for sure, for sure. So, yeah. So maybe this is A1. So A0 is equal to 70. That's actually kind of cool to think about. Week 0, yeah. There was 70 over 3 before it even started. Okay. I see. They do it in this form. They say A sub n is equal to that A sub n minus 1. That's another way to do it. So this, or you could say like A sub n is equal to 3 A sub n minus 1. Does that make sense, Blue? I always forget like what form they want it in. Yeah. Oh, I see. But they do it this way at least. Yeah. This is cool. This tells me A sub n, right? This is always like the common ratio. So this is the factors going up. This is 2 times A sub n minus 1. I did. Yep. Yeah. This needs to go over here. I realized afterwards. I made mistakes. It's okay. Explicit formula. So wait, isn't that already given? Oh no. I see what they say. Wait, okay. The explicit formula here. So this tells you that R is equal to 3/4. And then this is, yeah, A1. So you'd say that like A sub n is equal to 600. And then we would say 3/4 to the n minus 1. I think that's correct. Include at least 3 terms. Okay, so that's like 600. And then it goes by, it drops by a quarter. 3/4 of what you had is a quarter less than what you started with. So a quarter less than 600. A quarter of 600 is 150. So this goes to 450. And then a quarter less of 450 is, what is that, like 117? So are they like 323 maybe? This face when you're expecting some explicit and it's just a freaking algebra formula.
Disqualified.
Biggest disappointment, dude. Yes. But we could do that this way with our calculator. We could say 600 and then times 0.75 times 0.75. Was I right with the 323? Oh, 337. Okay. I was close. It was the other matchup to 350. Possible scenario. Here's a good one. You start with 600 ChatGPT credits. And you lose 25% of your tokens every hour to coding the most beautiful app. That's how it works. Yes. Okay. This one. Geometric series. Okay, so it's just doubling, right? So that's 10, 20, 40. Yeah, they really don't want to call it A0. Yeah, it's I hate when they do this as n-1 stuff. No. Like, in coding language, we know things start at 0. They don't start at 1. Okay. Dude, how does Big Cars have 5,000 votes? Big Cars, you figured it out. Someone figured out how to already game the algorithm. Oh, I'm gonna have to debug this now. I was like, Jesus. You found it, Big Cars. Congrats. Okay. This could be I don't know, like bacteria growing. Okay. Hope that helped you out. Thanks for waiting, Blue. Appreciate it. You're just voting every 5 minutes ish, and it is working. That's crazy though. So what that tells me is I need to decrease the bonus, because 15% is apparently too heavy. Because you were able, or maybe I should let it happen. I don't know. Okay. Wait, did I save blues? I was like, let me save blues. This is blue. There you go. Good job, Blue. Thanks for waiting. That is cool, Big Cars, that you were able to vote every 5 minutes. And, you know, for that, let me check. What is your question? Can I do your question quickly? Yeah, I think I can do this. Whatever. Let's just do it. Here, I'll do yours, Blue, as a thank you for stress testing what happens if someone's like really dedicated. If we want to, we can also still vote for it. Let's see if Diddy would have won though. No, right? Okay, it would have been you. Okay. Oh yeah. Congrats. Okay. Cool. Yeah, setting up the integrals. All right, so let's see. This is volumes of revolution, right? So y equals 0 would be here to cosine squared of x from negative pi over 2. Okay, so I don't know, I feel like that just interesting. The rotation thing. We love the rotation thing. I put out a 4-part series of this on TikTok. Okay, so cosine of pi over 2 is 0. Right, so it's going to do this, basically. It's interesting it's cosine squared. All right, cool. So this is the area that we care about, yeah? Let me highlight it in gray. Okay. Revolving around the x-axis. Okay. So if you're revolving around the x-axis, this is a horizontal axis, which means I'm going to use washers for all these. So this is just going to be dx. So we know this is pi, and then this is r outer squared minus r inner squared d something. Because the axis of rotation is horizontal, this becomes dx, and then the bounds need to be in terms of x. The bounds go from negative pi over 2 to pi over 2. And then R outer, R inner, where, well, R inner is 0 because there is no, like, there's no, like, gap, right? The axis of rotation connects to the volume of revolution. So this is 0. So then R outer is just equal to whatever this distance is. This right here is going to be R outer, which is the same thing as the y value of the function, which is cosine squared x. So this is just pi integral negative pi over 2 to pi over 2, and then that's going to be cosine squared of x squared dx. And so this integral kind of sucks. No. I wonder if no, I think you just have to do it. But anyways, okay, there's that one. Sometimes this is where, for instance, the shell method comes in handier. It's a power reduction formula. Okay, yeah, that's what it is. The power reduction formula works when you have powers like that, but also the shell method makes things nicer if solving for like arc cosine, for instance, would make that an easier integral to deal with. But yeah, I don't think integrating arc cosine works either. Okay, if we're revolving around y equals 1. Oh, okay. So that's revolving. Oh, this is actually really fun. Okay, so now we're revolving around here. Would it be the half angle formula for cosine? Yes. Yeah, the half angle would work too. And then you'd have to do u sub, right? You could. Yeah, you could. Yeah, which is kind of the reduction. Okay, if this is y equals 1, it's still a horizontal axis of rotation. So we still have y is equal to, and this is going to end up being dx, and then we're still going from negative pi over 2 to pi over 2, but now r outer and r inner change, okay? So the outer radius is always going to be equal to 1, right? Because you see, like, the distance from here to the outside part of my volume of revolution, that's always going to be 1. So you have 1 squared minus, okay, but now I need to get r inner. So r inner then refers to the distance from here to the inside of my volume of revolution. This is going to end up looking like kind of like a cone. So this distance, that's r inner. And what I know is that this whole distance is equal to 1. And then this distance right here, that's equal to the y value of this function. And so that's equal to y is equal to cosine squared of x. So if I want the inner radius, I need this big radius, 1, minus this smaller distance, which is from the function to the x-axis. And so you end up getting that, okay, so r inner is equal to 1 minus cosine squared of x. Okay? And then that can go into here. So this would be 1 minus cosine squared x squared. And then this is actually kind of fun, because when you do this integral, 1 minus cosine squared of x is the same thing as sine squared of x. So in reality, what you end up getting for the integral is y is equal to negative pi over 2 pi over 2, and then this is 1 minus sine to the 4th of x dx, which I don't know, this kind of becomes a mess, but I leave it as an exercise to the reader to do that integral. I think this is a simple integral to do, but then this becomes another power reduction. It's a shame this isn't odd, because then maybe this would go to 0, because it would be symmetric. If you're integrating like If you were just integrating sine from negative pi over 2 to pi over 2, you'd be golden. The answer would be 0. But it's sine to the 4th. Yeah. Okay. Does that kind of answer your question, Big Sports Car? Big Sports. Yeah, odd and even and trig. Yeah, okay, sure. So, if you had a function, let's say, for instance, just like sine of x from negative pi over 2 to pi over 2, sine of x looks like this, right? So if you integrate sine of x from negative pi over 2 to pi over 2, it's symmetric. So the negative area here cancels out the positive area here. And so this integral ends up equaling to 0. That's because it's an odd function. I think this would also work with sine to the 3rd or sine to the 5th, right? The issue is when it's sine squared, okay, well now technically this thing comes up here, right? Because negative values aren't allowed, they get squared and become positive. So now you can't...
Surprise, motherfucker.
You can't make the symmetry argument for it being 0. It's something to look out for a lot with integrals. It'll make your life easy if you can just make arguments that, oh, you know, it's an odd or it's an even function, and if my bounds are, you know, symmetric like that, then the integral just goes to 0. For instance, if you had the integral of like x to the 3rd from negative 2 to 2, this would be equal to 0. This is an odd function, and you have symmetric bounds. Because if you integrate this, look, you get 1/4 x to the 4th, and if I do that from negative 2 to 2, right, and I plug in, I just get 1/4 2 to the 4th minus negative 2 to the 4th. This goes away. Yeah. But cool. Good question, Big Cars. Appreciate it. Okay, cool. Let me end out the stream. Okay, cool. Thank you, everyone, for coming to Actual Education Office Hours today. Appreciate all the questions. Big ups to Zach for helping me out with Laplace transforms. I really appreciate that, Zach. You're a gem. And then also, thank you, everyone who was a part of testing the new Q system. Let me know how it goes, or if you have any feedback or things. Yeah, thank you. You're very welcome, guys. I think moving forward, I think I'm gonna leave the multiplier as it is, because only one person really took advantage of it, and I want to reward you, big cars, for at least hitting that button every 5 minutes. It means you're really engaged. So I don't know. We may need to nerf it in the future, but I think it's cool for now. Anyways, yeah. If you want to go figure out all the other awesome people that are streaming, please go check out our calendar. It's on the same website that you use to submit your questions. Just click on calendar. And then, what's up, Haunted? There's beautiful array of content. So, tomorrow, Zach, at 11 a.m., we'll be doing differential equations. I will probably come by the stream so I can go learn some Laplace transforms.
That's dope.
Math Pond's doing some more exercises. And looks like Penn Center's doing logic. Ooh, I like logic. Yeah, I've taught logic before. Our next stream will be on Thursday. Same time. We're actually an hour earlier. And then make sure to also go vote for your game of the week. I think chess is winning so far, but if you go join our Discord, which is here, click join our Discord, you can then also participate in all the other fun events we do. So, yes. All right, let's go raid somebody. So if you're following us on Twitch, we're going to go say hi to someone else who is streamereening today. Who do we got? Got some DJs, Nerduino, Melissa in Denial, Carbon 14 Dating. Oh, this looks pretty cool. I think this person was... Oh, they do like Egypt stuff. Okay, go say hi to them. I think they're part of Knowledge Fellowship too, TKF. I think... yeah, didn't they do the seminar this month or last month? Anyways, okay. Peace out. We'll see you Thursday.
back. Ah! Actual education! This is very ironic. Hello, hello. Welcome on in. No, I did the wrong shout out every single time. No, don't. I'm not. Welcome on in, Raiders.